We cannot hear you, Pierre.
Phone. Apologies for the mishap. So welcome everyone. The SP Technical Section for Well Integrity is pleased to present this webinar titled Verification of Production Packer as Barrier Against Cement Bond. My name is Pierre-Edouard Vincent, and I'll be your host together with Jovan Stojkovski. Today's event has been scheduled for 60 minutes, but will not have a hard stop. We do encourage you to ask questions throughout the event. For this, simply create comments from the platform you're using, LinkedIn or YouTube. We have included a link on LinkedIn directing you to YouTube in case you'd be struggling to join the event. And before we start, I would like to announce a few updates. So we just concluded the Well Integrity Workshop 2025 in the Netherlands last week with 141 delegates, which makes it the biggest workshop in SPE. So another successful event. And also on webinars, we want to propose a few before the end of the year. So stay tuned for more info and look on the LinkedIn page. It's now my pleasure to hand over to my co-host and fellow WITS officer, Jovan.
Thank you, Pierre. So today we have interesting subject, and we have speakers, expert in their discipline. So I'm pleased to introduce Alexandru Andrei, who is a senior completion engineer within the OMV Petrom with more than 11 years hands-on experience in the well completion. He has played a key role in the major project across the Europe, deep water, Black Sea, North Sea, and the Middle East operations. His career reflects a strong dedication to service quality, technical excellence, and continuous innovation in completion technologies. Alexandru's extensive exposure to varied and demanding environments and has equipped him with expertise and commitment to deliver impactful and contribution to our energy sector. Welcome, Andrei. And second with us is another Andrei Timonin, who is working as a production service domain champion for Schlumberger Reservoir Performance Division in Algeria. For the past 23 years, he was working for Schlumberger in various locations, focusing on cased hole wireline services used for cement quality evaluation, corrosion assessment, production logging, perforating, and mechanical intervention services. His main focus area is to propose solutions for diagnosis wells, production-related problems, and provide support for selecting optimal remedial operation or intervention scenarios to rejuvenate production. So very interesting subject today of verification of production packer as barrier element versus cement bond. Today, hello both, and it's a pleasure to have you here today, an opportunity to hear your experience regarding this topic, which will touch many oil and gas and energy operators, especially ones who encountered annually pressure during the well life and during the well production. So let me start with fundamental questions, and I will appointed Andrei Timonin now. So hello, Andrei, and it's a pleasure to have you here. We will start with one of the simple questions. Could you please tell us the importance of good cement behind the casing on the well integrity during the well life and challenges which arise during operation?
Hello, Jon. Hello, everyone. Good morning, good afternoon, good evening. It's really my pleasure to participate in such a great event. And thank you very much for your kind invite. And thank you, Jovan, for very interesting question. So as we know, in oil and gas producers, when zonal isolation fails, hydrocarbons production is severely degraded. And in fact, in some cases, wells might be lost completely. So same is true for injectors, in which injection efficiency can be impacted due to bad zonal isolation. So such failures present environment and safety implications, since hydrocarbons or, let's say, previously injected fluids might flow to the surface or into the nearby aquifers. Thus, it's not sufficient to obtain good zonal isolation. The resulting seal must last for many years beyond the life of the well. And as we know, the obvious key to long-term zonal isolation is to obtain a good cement seal in the first place during cementing operation. And to obtain that good cement sheath, it demands adherence to well-established operating procedures, practices of hole preparation, casing centralization, casing rotation, and so on during cementing operation. So problems that can occur while running in hole casing and cementing can create some conditions that may lead to loss of zonal isolation. Among the most common problems is casing centricity from poor centralizers positioning. Cement, like all other fluids, seeks the path of least resistance, right? So it flows to the more open side of the casing, creating some channels in the narrow path. Another possible problem that we could see is inadequate cement slurry density. So that can also allow formation fluids to enter the wellbore and create some weak points or gaps within the cement sheath itself. And as a result, that cement can fail under some stresses. Other problems that we could see also is the geometry of washout areas that often results into inefficient flow rates during wellbore cleanout operations. So that leave drilling fluids behind. So as the result, these contaminants also lead to weak spots in the cement sheath. And if they are large enough, or if there are too many of them, they can create some channels through which formation fluids can migrate or can flow. So all these aforementioned factors, all the factors that I just spoke about briefly, do impact the quality of cement sheath and hence the zonal isolation. So back to you.
Thanks, Andrei. Of course, we are looking for a very good cement in our well construction, especially that during whole well life, we need to ensure that our barriers contain and isolate hydrocarbons and any kind of the influences which can come if our cement job is not done very well. But here we will touch also the base principle of the well integrity, and I will now pass to Alexandru Andrei to tell us a bit of the primary well barriers and to touch the packer as a barrier during the well production or injection phase. Andrei?
Hi everybody, hi Jovan, thanks for the great introduction. And yes, as Andrei before mentioned, cement integrity or zonal isolation is critical for the entire well life, and it's not only important to have a good test today or tomorrow, it's important to have the integrity for the entire well life, and basically from drilling and cementing until we P&A the wells, and also many years beyond P&A phase. And I want to guide you, and before going to the packer as a barrier, I want to guide you to the entire well life and to share the importance of cementing operations and the importance of each barrier during the well phase from drilling and production. And in the first photo, we have like basically an operation which is 1338 cased well. So basically you have the primary barrier, which is the killing fluid, and then you have the secondary barrier. Then once you go towards the well life, you pass to the other section and you will end up to drill the 12.25 section. You do the logs, and basically you cased another 958 casing. Further on, you will finish everything, all the barriers in place and validated. You continue with, let's say, maybe there is a production line at 7-inch with 8.5 section. Always you have to maintain the barriers. And then if you go to something, let's say, more complex, after we finish the drilling and cementing all the production casing or liners, you need to put the well in production. So my idea, which I want to stress, that the cementing operations are critical, because this I consider which is the permanent barrier there. So you cannot do anything at all unless you need to do a costly sidetrack or a brand new well, which is a P&A. So the cementing operation is like foundation of well integrity, including zonal isolation. Later on, if you discuss the secondary barriers, which are the packers, when we run in hole, there will be always a packer, which during the nipple down BOP and other operations, the packer is a secondary barrier. But once we put the well in production, the packer basically, and all the completion accessories, including safety valve and the landing nipples and the plugs, are the now primary barrier. But this only during the well life, after we perforate the well and we put the well in production. And I like to say that the packers, regardless, are retrievable and permanent, and all the tubing and safety valves, these are retrievable barriers. So in case of a failure, there is always shut in production, a costly workover, but you can do something. So you can intervene, snubbing, workover, rigless, to run straddle, to prevent or to patch a tubing hole or whatever. So I like to make this categorization, 2 different barriers principles, the permanent ones, which are very important, and then they have the retrievable barriers. And of course, if you want to stress only on packers as a barrier, apart to the cementing operations, now there are the zonal isolation packers, or there are the suppliers with metal to metal packers, which are V0 validated, or there are swellable barriers. There are many different types, but still cement should be the primary, and the cementing operations are critical for entire well life. It's basically the foundation of the well, which protects, including the drilling crew, the drilling rig during drilling, and also protects the production on the later life of the well.
Thanks, Alex. I will move forward with putting the light on the packer as a primary barrier. As you said, it's isolating our reservoir fluid from the rest of the production casing, protecting our casing from corrosion, deterioration. What are the common ways after we run the completion and set the packer? What are the common validation of the packer as a barrier, as a common practice in the completion operations?
Common practice is always to pressure test the A annulus after you test the packer, and then you test your string. But mainly when we run in cemented environments, if you discuss about cement before perforating the wells, what I would say, it's a barrier is validated when you test it from the direction of flow. So when is the case, you run the completion basically in a cemented liner, cemented casing, and the well is not perforated, the ideal case is to test the tubing string and the packer, including the production liner or production casing, which is all exposed below the packer, to the maximum anticipated shut-in wellhead pressure. And this will validate basically the packer as a barrier. During production, you will have, when you have the packer from secondary to primary barrier after you perforate, and in this way you validated the packer seals, regardless it's V3, V6, or V0, or V0 air as per latest API, the 4th edition. If you can test it from below or from direction of flow, this is basically, I will say, the key principle of a validated barrier.
Thank you, Alex. So setting the packer as a barrier, we need to look what is behind the casing. Basically, we need to choose the place where to set the packer, and most operators will tell us that the packer should be set inside the, let's say, area of the impermeable rock, so the cap rock. But as a completion engineer and well integrity engineer, definitely I will look on the condition of the casing behind. So I will pass the ball to Mr. Timonin, and I will ask what are the methods if we see in front that we will have some difficulties during cementing job, that we have a layers maybe with a possible gas which can migrate through the cement and basically create some pores and channels in the future. What we can do to strengthen and plan better our cementing job in order to have a very good cement behind the place where we plan to set the packer. What is your experience and what you can recommend?
Thank you. So basically, yeah, I mean, definitely before setting packer or deciding where to set the production packer, we should look at the casing condition just to make sure that it's not deformed, as well as cement quality behind it. So if we do see some anomalies in the cement sheet, like channels, as you mentioned, maybe some extended gas filled or liquid filled channels, we might think of doing some remedial operation before proceeding with the packer setting operation. But again, all depends on the location of those channels and the fact that if those channels are connecting some critical layers, like, I don't know, let's say some high pressure hydrocarbon bearing layers with some aquifers, as an example. So we just have to ensure that there is a zonal isolation across a zone of interest before we proceed with the well completion. And just to ensure that the well or casing is cemented properly on the first place, I mean, we just have to adhere to the well-documented practices. I mean, there are some local practices on how casing or how liner should be centralized, how many centralizers we should use, where to place them, what should be the recipe of each particular cement slurry for each particular section, should we rotate casing or not during cementing operation, and so on. So, I mean, I'm sure that every company in every single location, they have their own well-documented guidelines on how to cement every particular section to avoid any kind of problems, like, as an example, channels, right? Formation of the channels in the cement sheet.
What mitigation we can take in consideration as a contingency if we are very close and to recognize those events, and nevertheless we decide to run and cement, what we can put as a contingency in that moment? Yeah, so we have difficulties passing and drilling, and then we run the liner or the casing, and we observe difficulties to pass the certain depth and to set the casing where we want, and then we, let's say, encountered the high possibility that the pumping the cement, we know that will not come on the designed depth, and we are very close to fracture gradient in that moment. Are you recommend that we change maybe the recipe, or to do some pulling the casing, condition the well, and continue in the better prepared, let's say, open hole to run, or there is anything which we can install in the casing that we can prevent future sustained casing pressure, if you said that we have maybe high chance and high possibility to have some channeling after the cement is cured?
Yeah, I mean, if there are some issues running in whole casing to the desired depth, or let's say, or if you observed some formation collapse at some certain depths, I mean, probably the easiest way would be to pull out of whole casing or liner, if possible, of course, and just to drill that section with the drilling BHA, just to make sure that the casing or liner can be run safely. I mean, from our experience, what we see is casing or liner centralization is one of the most critical aspects in achieving good zonal isolation. So once casing is very well centered, okay, and the cement slurry is designed properly, and that there are no big washouts, I mean, you can expect to have a good cement sheath that provides zonal isolation. So before, even like as a contingent, right, before running in whole any casing or liner, what we do typically, we run caliper tools, open hole calipers, just to make sure that there are no obstructions, right, or no big washouts across liner setting or casing setting depth, and to ensure that there will be no issues while running it in whole. But sometimes, as you said, I mean, we do observe some issues.
Thank you, Andrei. I will pass to Alex. Alex, how completion can help us, example, in combination for running the casing to maybe put as a contingency something that can, after the cementing job, if we are going in the zone that we expect some problems, that we can maybe downhole, try to isolate, and then prevent any migration of the gas or high water layer to be present in the outer production casing area, which is B annually.
Interesting question, Jovan. There are different ways, but depending of the difficulties which we encounter after cementing operations. But just to jump to the other Andrei topic, centralization is key. The slurry is key, but also the flow rate is the key. So basically, we need to take all the mitigations and to ensure that we are doing our best to have enough flow rate, to have a proper cement placement and drilling mud displacement. Going back to your question, there are different tools in the market and many service companies around. But basically, let's say we have a liner which is not cemented, it's cemented, but we see poor cement job after a week or two. We can't do much unless there are different ways, like run casing expansion tools to expand the casing across the shale just to get a zonal isolation and to prevent unwanted water to go into the lower reservoir or higher reservoir with the hydrocarbons. But still, I would say that cementing operations are critical, and basically the life of the well depending on the integrity which will be coming from cement and zonal isolation, including the casing in the design.
With going to the completion tools, can we install casing annually packers, and how we can rely on them to basically mitigate the bad cementing job and isolate the layer which are below with a maybe high pressure and the gas layer, to basically isolate them and to not get them exposed in the B annual?
Yes, if we have concerns or if we know from the history that we could not have like 100% or ideal cement job, and we tried many times well by well and we had issues, a backup to the cementing operation like a zonal isolation packer or annulus packer or even swellable packer, which is the previous, like the traditional way, is always welcome to have, regardless is below the last casing shoe or somewhere in the casing, but not too close to surface, to be around the previous casing shoe track, as per my recommendations. A secondary barrier is always welcome. So, but this depends also the limitations during cement, because you have a restricted flow path. We have a different bigger OD, which can prevent or can have issues during the circulation or cement displacement, or any other limitations. There are packers which can be set with differential pressures, which you need to consider or to mitigate with the risk assessment during cementing operation. But the overall, just to answer your question, yes, if we know that we have issues in another specific field or reservoir, to drill and get zonal isolation and to prevent hydrocarbons in B or C annulus, a secondary packer or A annulus zonal isolation packer is always a recommendation.
Thank you, Alex. I will back to Andrew. Andrew, our wish as a, let's say, completion engineer to set the packer and test our annuli. In case of any leak of the tubing, we will expose this A annuli pressure with a high stress, which will be leak from the formation. So formation pressure will act on the top of, let's say, very close to the surface if we have a leak, will act on the column, which is hydrostatic column inside the annulus, and press on the packer depth. So our biggest fear is in this moment how the cement is acting behind. We are talking about the hard cement, and after a while we want to test. So even not during production, with the initial completion, we are concerned to not crack cement and to create micro annuli if we wish to test our A annulus up to the reservoir pressure, which is our, let's say, one of the things which will occur during the tubing leak scenario. So we want to validate the casing to be sure that if leak came, that we are safe. So how cement will respond and how we should be, take this in consideration during this, let's say, the ultimate stress which cement will see behind the production casing.
Yeah, that's a very interesting and tricky question, Johan. Thank you. So, as we mentioned, we all agree that the cement that is placed behind casing or liner is expected to provide zonal isolation throughout the life of a well, right, and beyond it. So, but its ability to do so will depend on the proper placement of the cement on the first place, the mechanical behavior of the cement, and the stress conditions in the wellbore that either we apply or that comes from other sources. So even if the slurry was properly placed, changes in downhole conditions can induce sufficient stresses to destroy the integrity of the cement sheet. So, and we have to take them into consideration. Just to give you some example of those stresses, right? I mean, those are the stresses that are imposed on cement while doing pressure integrity tests, as you mentioned, while changing mud weights in the wellbore. They also could be during perforation or stimulation processes, as well as due to large increase in wellbore temperature during production period. So any of these events can damage the cement sheet. And often the damage to the cement from these events results into microannulus, okay? And as we know, microannulus is a very small gap or teeny gap in between cement and outer casing walls, okay? So this microannulus is so small in size that it is really hard to repair. But at the same time, even the smallest microannulus can be large enough to provide a pathway for gas migration, resulting into sustained casing pressure over time in some wells, right? So despite the changes in downhole condition over time, right, both which we can predict and unpredictable or unexpected, our main ultimate goal should be obtaining long-term zonal isolation. And basically, we have to keep in mind that it will have some environmental impact, right, as we've discussed. So that's why it is mandatory. And to do so, what we have to do is just to select the right technology, use the right process, and use the proper evaluation tools for cement quality diagnosis. So as we know, throughout the industry's long history of using cements in well construction, I mean, cement slurries, they are evolving, right? I mean, it's not the same technology, right, anymore. So they are evolving such that nowadays there are some advanced flexible cement technologies that can handle changes in stresses imposed on cement sheet. And the mechanical flexibility of these cement systems allow the cements to resist failure up to some extent, of course, during hydrostatic pressure fluctuations. As an example, pressure tests that we were speaking about. Also, unfortunately, just to answer your question, there is no straight answer on that question, because the safety envelope for hydrostatic pressure fluctuations during pressure testing operations that can damage the cement sheath behind casing will depend on many factors. Okay, so it will depend on actual casing size, weights, as well as cement properties such as slurry density, Young's modulus, and so on. So in the industry, cementing experts, what they can do, they can use some specialized cement sheath stress analysis software to analyze the radial and tangential stresses imposed on each casing string during some events, like a pressure test, as an example. So in addition to that, those software can predict the performance of the cement in compression, tension, or both, and even some software have ability to establish parameters including set cement flexibility, support, as well as the standoff. I mean, in other words, micranulus. So simply speaking, some software can also predict how, if micranulus will be formed and how it will develop over the time when you subject casing to certain kind of events. So such softwares can be used to help selecting and designing the cement systems that can extend well life for sure. I mean, again, depending on every single well that you have to be analyzing. And typically, whenever you do such analysis, the first step would be to determine if well requires some conventional system slurry or it needs some specialized cement slurry. And if special cement slurry is needed, okay, the second step would be to analyze different scenarios to design the cement system whose Young's modulus would be below the stress levels that the software would predict that cement will fail. So in other words, if you're planning to apply some certain pressure test, let's say 5,000 PSI inside the well, so by running that software, you can predict if your particular cement slurry will fail or not under that stresses, okay? And of course, the final step would be to, once you select the optimal cement slurry, you go ahead and you test it in the lab just to make sure that it is meeting the requirements. And then, of course, you go ahead and you pump it in your well. So I hope I answer your question.
Yeah. Before I go and put the question from the audience, there is a couple of questions that's still not clear, and we came today here to touch how much we can pressure test the packer installing the well and to not crack the cement, but still would approach of maximum expected shut-in pressure to this value to test the casing while the cement is still green, and to relay to confirm that our barrier will withstand this pressure and record it for us as a validation. And after installing the packer in the well, we can apply then less pressure because the time will pass, the cement will cure, and to, let's say, not crack the cement with a higher pressure. What is your point of view on that? I will address to Alex, and I will come back to Andre later on. I am curious to find out your opinion.
Yeah, this is the hot topic across all the companies between the drilling and completion engineers. By experience, or let's say by the book, the green cement test is the one which should validate and should test all the casings or the production casing which will to the maximum anticipated surface pressure during entire well life. Pressure tests, tubing leak during production. So basically, green cement test, I believe it's each operator has his internal rules or practices, but it's the most common test which you can do and to don't harm the well. Later on, after the cement reach, let's say at least 500 or 1000 psi compressive strength, if you want to test again the A annulus, which we discussed a bit about A annulus and the packer as a validation on the A annulus side for production operations or entire well life, here is a bit tricky. All these things needs to be mitigated with the risk assessment, choose like flexible cement slurry, and so on, so different chemicals, and the discussion is a bit very complicated because there are studies which shows that logging operations or ultrasonic operations for a casing done after the green cement test a week later, once they test or they stress that casing in the lab, in the test cell, they repeat the ultrasonic logs, they've seen that microannulus appear. There are studies and there are case histories which validates this. This is why I will stress for the green cement pressure test, which is also again the very first test. Everything will not harm anything to test your well to the maximum anticipated surface pressure.
Thank you, Alex. Andre, what is your point of view on that? Shall we test the green cement casing up to the maximum shut-in pressure and validate as a barrier, and not stress in the later days when we install our initial completion?
Yeah, that's a very tricky question. I mean, I would definitely run a model, first of all, just to make sure that the stresses to be seen by cement are within the recommended range. I mean, so that we're not gonna crack the cement, but there is always a risk to develop or create microannulus that could possibly later cause sustained casing pressure on the surface. So while doing the pressure test, I would say, I mean, if cement is green, that would be more advisable, but it's not often possible because by the time we run completion, cement is already set and it's in a solid state, right? So again, the model must be run, the proper software must be used to predict the cement failure and estimate those limits up to which you can test your casing, and then test the casing within those limits, recommended limits.
Before I go to the audience question, there is something crossed my mind. Andre, it's possible after you see the logs and quality of the cement behind to give prediction in case that we as a completion engineer approach you and said, we need to know if we test to certain pressure in this well, can we expect any microannuli creation or cracking the cement behind? Would your expertise can support this information, or you have software which can tell us something closer that we are entering the risk, or we should go lower on the validation of Packer as a primary barrier?
Yeah, so nowadays, I mean, whenever we do cement quality evaluation logging, there are some certain technologies that allow us to locate places where we have microgranules and even tell if those microgranules is filled with liquid or gas. So simply speaking, is it like a wet microgranules or dry microgranules? So running logging before pressure test and then after pressure test, in theory, you can evaluate if microgranules was formed as a result of that pressure test or not. So you can, in fact, by looking at the real measurements, you can check if the microgranules was formed or not. So all that information again can be used to decide if pressure tests on your Packer should be made in any kind of subsequent wells, you know, and what should be the safest envelope to do so.
Okay, so moving on our audience questions, one of Alan asked, can you give opinion on what defines a good cement as verified by a given cement logging tool, and also your experience of minimum cement interval required for isolation versus those defined in the UK and also guidance? And I will extend the question, can you see the log in the well after we finalize, before we run the completion, and tell us this is the place where you can safely install a Packer as a primary barrier without harming the cement quality and sheet behind? As a recommendation, can you recommend us the place where, and what is, as per your experience, the minimum which we need to have above the Packer setting depth, and what is, from your experience, the operator, let's say, standard or requirement to have in order to be sure that this is the correct place to set the Packer?
Okay, so to start with the definition of a good cement, I mean, whenever we say it's a good cement, what we are meaning is cement that is present azimutally all around the casing or all around the liner, okay, without any channels, without any artifacts, across certain length of interval. So if you speak about the minimum length of interval, I mean, some companies define it as a 3 meters. So if they see that you have good azimutally present cement across 3 meters, that place can be defined as a good cement in the annulus. Okay, and in fact, you can go ahead and set the Packer across that section firmly, right? So I don't know if I answered it. Yeah.
We've seen cases all around, yes, like you said, 3 meters minimum, like 10 feet. This is the rule.
Yeah,
but
yeah.
We've seen cases where, let's say, we were lucky across a coupling and we had like 0.5 meter or 1 meter, and 2 different perforation, 2 different casing joints, like 10 meters apart or less. We had zonal isolation, and we had no water influx basically from the lower zone. And all these things are not limited by any governmental things like the cement to surface or what is the overlap for in case of the well construction. But each major or experience shows how much do you need, or depends of the inclination, trajectory, pressure, or the downhole environment. It's very tricky, and there is no ideal answer to this question, I believe.
And I'll add something to that, Alex. That I think it's project dependent. Also, there's so many variable for each asset that one thing you haven't really mentioned yet is the learning cycle. So how what you see in the field should really influence how you place your slurry and the procedure. But there's another question by Wakas at this stage, so I'll show that. Maybe we can take this one. It's about practices.
So basically, from your operational experience, how do rotation, reciprocation, or combine these two motion during cementing influence fluid interface stability, removal of the drilling mud, and ultimate long-term well integrity? Which mode of movements provide the most measurable improvements, I will guess?
Yeah, so the way how it's explained is very correct. I think we started running casings and cementing 100 years ago. And by that time, I believe our predecessors, they just run the casing and circulate and spot the cement. Later on, issues came and what you can do. Basically, you can do many things in the oil and gas. They started to say, okay, let's circulate and rotate. So then basically the rotation was included to the market and things were changing and improving. We've seen the desire or the appetite to go to deeper and more challenging environment or wells or bigger production. And then the issue came that everybody said rotation is not enough. And then reciprocation was added as a mechanical thing, because in oil and gas, you can't do much. Just rotate to left or right, pick up, slack off, bleed off, slow, increase the flow rate or decrease the flow rate. I believe these are the main topics. So now when reciprocation and rotation was added to the cementing operation, basically try to fill all the gaps. And it's clear evidence during even a liner or the cementing, if you can rotate and reciprocate, you will have a better cement job and better casing adherence to provide your zonal isolation. So I believe, yes, reciprocation and rotation, if it's possible, and you are not limited to the well trajectory parameters, downhole tools which can have different limits, start to set or what torque limits. If you are not encountering these showstoppers or limitations, yes, reciprocation and rotation, it's definitely a yes.
And practically, Alex, I think in confronted with delivering wells for a specific asset, then an engineer would have to ask the right questions. Can I centralize well enough? Can I rotate? Can I reciprocate? And a lot of projects, when you start running casing, you can't even pull it out. So it is going to go down. So you will cement in the situation that you have to live with. Now, where I think we can probably do a little bit better is to look at advanced, a bit more engineering and think, okay, well, when is my cement going to set exactly versus bumping the plug, pressure testing the casing, then pressure testing the annulus. Do that at a time when you have placed the maximum, or you're not doing that in adverse conditions when cement still doesn't have the right compressive strength, and you can do a bit more than what is often done, which is routine, cookie cutter delivery. Abdelrazak has another question, so maybe we take this one.
So the question is towards workover operations, and shall we test the outer annulus during the workover intervention if they don't show any present pressure activity before? So whenever we entering the well, shall we test them? What is, Alex, your experience with the workover operations?
That's very true. Very good question. I believe we cannot predict, but from experience I can say like this: when the operators will see a B, C, or D annulus, the first thing it's basically bleed off and let's pump something to stop, to have zero on surface. Let's plug this whatever space between B, C, or D, which will not always work. some of the operators are saying they just do an injectivity test to see where they inject or try to pump some polymers or pump cement to do a cementing remedial job. Some operators are doing ultrasonic logs to determine from where the leak might come, or then they do a technical perforations, and with the cement retainer or other ways they do remedial jobs. But definitely should count your steps, because any pressure test which you do against a B or C or D can open a different layer, and you can make even more damage unless to control, to constrain, or to bleed off. And then even there are cases where basically you take samples, if it's gas, water, what kind of water, then you take this to the lab, and then based on your field experience, you need to understand from which layer is coming to see where you have high pressure or other production layers which are isolated by the B, C, or D. And yeah, you need to measure your steps and to do very close risk assessment and the program to don't harm more, because then you might end up to lose the well.
And I would add to Abdelrazak question that it should be part of the normal surveillance program. So we need to top up and pressure test and keep a little bit of pressure on your outer annuli, because if you don't, then you might have a surprise when you do the integrity testing. So before a workover, absolutely know the integrity condition of your well before you embark on a workover. I think it's only common sense, because things can evolve, and then you're blind. So we'll take the next question.
I can also complement, if you don't mind. I mean, so basically, again, as a part of the remedial operation, just to complement what Andrei was saying before, is we can schedule the proper logging program, especially if you suspect some crossflow between layers in B, C, or D annulus. You can define the proper logging program just to verify that there is no crossflow across zone of interest. Also, you can also evaluate an option to evaluate cement quality in A and B annulus. Again, all that can be defined as a part of your remedial operation for that particular well, and all depends on the well completion, on the objectives for that remedial operation, and so on. But
and on the
remedial, logging is a critical step. Yeah, exactly. Yeah,
and on any remedial operation, I would personally be very careful not to make the situation worse. So, because remedial, once you start punching holes and trying to inject things, you potentially have created a problem where you didn't have one before. But so I've showed Ian's comment, I think, for long enough, but he has a good point. There's been a lot of recent advances on understanding potential changes in the cement and how that might affect flow. So there's a question by Imtiaz on smart cement that could potentially heal and swell in presence of hydrocarbons. Any experience with that in Algeria?
Yeah, so there are different cement slurries flexible cement slurries that do expand under certain conditions, as well as they heal themselves when they get in contact with hydrocarbons, again, up to a certain extent. As of today, as per my knowledge, we don't use those cement slurries in Algeria, but they are used globally in different locations, again, depending on the project itself. But typically, they do provide quite good results. I mean, like, they've been several published SP papers about different technologies and the results for the zonal isolation that they provide. Especially, this could be valid for gas wells or CCUS projects. CCUS project wells, when zonalization is especially critical, and you need to prevent CO2 migration. So yeah, I mean, they do give good results. This is what we've seen.
And have you seen, so this is one question I would have maybe asked earlier during the discussion, is how many wells do you see in the project you're involved with that kind of form the basis of your opinion? How many of those wells have sustained casing pressure? We're doing something wrong, you know. Basically, if we see sustained casing pressure in some wells and not in others, then we can think, okay, well, we must have done something wrong in the wells that have sustained casing pressure.
Yeah. So again, you know, like for the flexible cement slurries, they do have some certain limits, right? In terms of the expansion ratio. So basically, you have to design the slurry properly, and you have to take into account all the stresses to be seen by the well throughout the life of the well. So as long as you do your homework and you predict that, and you can design slurry to cope with that pressure fluctuations. Coming back to your question about the sustained casing pressure, we do see in multiple wells here, at least in Algeria, I mean, that some of the operators, they do observe sustained casing pressure in A, B, and sometimes even in D annulus. This is especially valid for the gas fields, okay? Because as you know, gas is very mobile.
It will find a way. It will find a way.
Exactly.
So I think I mean, considering what's been said and what Kirk is saying, so yeah, we tend to say we are at a time now where we can combine various models and look at what could affect in our practices the potential for zonal isolation of cement in a variety of scenarios, including depletion during production, various pressure tests, etc. We don't do that very often, but I think we should do that for the more demanding project to avoid facing integrity issues that are more complex to resolve. And I'll show one question from a comment from Sergei Feoktistov. It's an open question to you guys, but it's a big topic. How much we can understand of cement, you know, based on logs.
Yeah, I can take it.
It's a good topic for Andrei.
Yeah. So yeah, I mean, like if you look at the sonic tools in general, I mean, the ones that give us CBL/VDL data, right? I mean, this technology nowadays is what? It's like 65 years old, right? Or plus minus. It's a very old technology, and all what it gives us cement bond quality with casing and qualitative bond with the formation. So this particular technology will not be able to give you information on azimuthal cement placement. So basically, it will not be able to locate channels in the cement precisely. However, there are some ultrasonic tools, okay, that are capable to get or to evaluate cement quality with good radial and vertical resolutions. And by using all that data combined, you can, in fact, quite precisely locate channels in the cement, and you can even tell if those channels are filled with liquid or gas. Okay. Again, there are multiple technologies available in the industry. If you look at the ultrasonic tools in general, and all those tools are capable to detect channels in the cement. As for the noise tools, I mean, they are very useful to locate any movement, fluid movement behind casing in A, B, annulus, or whatever. Whenever you suspect to have some, let's say, cross-flow between layers because of the bad cement placement. Yeah. So I hope I answered the question.
Yeah, I think to the best of your knowledge, what I can say on also as a comment on that specifically is, yeah, sometimes the only way you know there's a flow is if you pick it up with noise log. The logs could still show that it's very reasonable and the movement of fluid is not exactly expected. But then depletion plays a part. So the fact that your casing may now be slightly contracted compared to when the cement was set, that also plays a part, etc. And maybe one more question because we're running out of time. No, I think we've run out of questions. There's been some feedback, but we're right on the hour.
Yeah, I would like to encourage all audience to comment on how they like SP with webinars, to comment which subject they would like to see. Feel free to join us on LinkedIn page, follow us, and send us topics which you think we should tackle here. Yes, Pierre?
No, I had so maybe as a final comment, because I wrote down on my notepad, meant potentially asking Andre if he, in Algeria, you were seeing issues with saline corrosion in surface casing, which can cause structural issues, and if geopolymer had been, tried there, potentially applied. New formulations of cement. Cement is probably going to be replaced at one point. It is carbon intensive. We're running out of Class G, etc. So we'll need to find a substitute. Any comments on that, Andre?
Yeah, so one of the issues that we see here for the layers close to surface is the cross flow from aquifers into the salt, basically. I mean, sometimes it becomes extensive, and sometimes those salty layers can be even dissolved, causing the earth subsidence on surface. So that's the biggest issue. But there are some certain layer, high pressure aquifers with a bit of saline water. And I wouldn't say that they necessarily causing the casing corrosion, okay? But because of their high pressure, the government demands to have very good zonal isolation across those aquifers and cover those aquifers with at least 2 tubulars, just to make sure that there are no surprises in the future. Yeah.
Very good. All right. Well, shall we wrap up, Jovan?
Yeah, we are a little bit extended than we planned, but really good discussion. Thank you, Alex. Thank you, Andre, on your contribution, on your sharing your thoughts and experience here. We're really looking forward to tackle more this subject where we will cross other disciplines and bring them all together and gather the people from energy sector and discuss topics which are related to our discipline and ultimate on the well integrity of the well to keep our well healthier for the longer period of time. This is cross experience exchanging is more appreciated for all of us, and I will look forward to invite you for another and upcoming session over the coming period. And yeah, Pierre, if you have anything to add, we plan to have in the 2026 to continue with this pace of the webinars. We will try to bring more experts in the different disciplines which touch not only well integrity, but as we bring here also the completion expert and the cementing expert on the same table. We'll just expand our knowledge and make, I think, a more clear picture on our daily work, what we are aiming to do, and the aim is to have safe wells. So this is all for today. Thank you, Pierre, for making me company and making this happen, and thank you, Alex and Andre, for your contribution today.
See you next time.
See you next time.
Thank you very
Thank
much.
you.
Thank you very
Thank you.
much.
Thank you. Bye.
Bye.
You know, people ask me why they should join SPE, and what I tell them is that SPE is absolutely essential. Frankly, if SPE didn't exist, somebody would have to go out and create it. when you graduate with a technical degree, a petroleum engineering degree, or other engineering degree, you get a lot of really good knowledge that gets you started on your career, and you learn a lot on the job. But the jobs that we have in this industry, they're really quite difficult. And you've got to have other resources, either to solve specific problems you might be having at the moment, or to better understand how to solve, daily issues that you work on. SPE provides opportunities to learn about new things that people are working on. There are great articles in JPT Magazine and the other magazines that we have that are really useful. If you're not reading JPT every month, I tell you it's essential to do that to keep up with the technology. We have excellent conferences where you can learn from people who have solved very difficult problems in our industry. And doing that is just incredibly important and incredibly useful. To me, I don't see how you can be an engineer working in the petroleum industry and not find value in the resources and the opportunities that SPE provides. It's an opportunity to meet people who can help you in the industry, and it's an opportunity to get the knowledge you need to be successful.